Okay, so welcome to How Secure is Your Linux Distribution? Or, if you prefer, the Linux Mint's Bash Fest of 2016. I am Matt Arnold. Who the hell am I? Or who the heck am I? I've been hacking on Linux distributions since I was about 17 or 16. Mostly Debian, but Slackware lately. So, I used to do mostly instant messaging software and IRC and various communication stuff like that. That integrating it with Debian, that sort of thing. And by the way, this is my first talk, so don't be too cruel to me. So, who here uses Linux Mint? You're probably owned already. Or will be soon enough. But, the inspiration for this talk came about in February of this year. Who here knows what happened to Linux Mint in February? Okay. So, anyone want to tell us what happened to Linux Mint in February?
The distribution download site was compromised and people were redirected for a few hours to malicious versions of distribution.
That's almost right. They compromised the distribution itself, the distribution download servers, and replaced the official Linux Mint ISOs with a compromised version. And by the way, since their distribution servers were also their website servers, they changed the MD5 sum on the website. So, but it got me thinking, what is a Linux distribution anyway? Well, it may seem obvious. It's the stuff you insert into your computer to make it go. Unless you're on Windows, in which case you're in the wrong room. But how a developer defines a Linux distribution is the Linux kernel, obviously, otherwise it would be a FreeBSD distribution, which Debian does also do. You should check it out, it's quite awesome. Together with a set of packages, a set of software, upstream software that makes a complete operating system. You can think of the Linux kernel as the CPU of the system. That way, it's the same analogy as the same CPU is in the NES, Nintendo Entertainment System, and the Tamagotchi, but they're different systems, right? No one got that analogy. So, depending on what the distributor decides to do, he can control almost anything. So the distribution is the OS, not Linux, not the kernel itself. The kernel only provides drivers and other such mundane stuff. It doesn't even boot itself without a bootloader, which is also provided by your distribution. So security engineering in the Linux distribution context is critically important for the whole Linux ecosystem. And apart from the major distributions, everyone does it badly. And it's not just it's not just Linux Mint. It's the firmware that runs inside your router is a Linux distribution. The thing that runs your TV is a Linux distribution. So what this talk is going to cover is how security engineering is done in the major Linux distributions so that if you're like an embedded systems designer, you can take some lessons from that. All right. So how do the big players define security? Well, it's not written down anywhere, but I've patched together a definition. So, no Linux distribution will be able to secure all the software all the time. There are vulnerabilities in packages coming out daily. Some are more critical than others, but almost every day Linux distributions, or at least the big ones, deal with security problems. So you won't be able to secure all the software all the time. So what a Linux distribution, or at least the big ones, Debian, Red Hat, etc., will try to do is not introduce any bugs, new security vulnerabilities themselves, and the parts of the system they do control are as secure as we can possibly make them. Usability and security are always a trade-off, so we can't go locking down the system and requiring it to run only signed binaries, or it wouldn't sell well as a distribution. So, and the other part is react quickly. The reason I know that security vulnerabilities are being fixed daily is because they are being actually worked on daily. And security teams know what vulnerabilities are coming up in the next week. And the next month. And you can't predict vulnerabilities, but as soon as one is spotted, it gets picked up immediately and worked on. Otherwise, people will hit you with bats, or call you up and swear at you in German. I've had this experience myself. At 2 in the morning.
It's vocal for that.
Yeah, but like, how'd they even get my phone number? It's like, so now that we've dealt with definitions, let's deal with specifics. There are multiple levels to securing an entire OS, and it's not just responding to vulnerabilities in software. It's also making sure they don't get there to begin with. So, and how do we make sure vulnerabilities don't happen to begin with? We secure the tool chain. GCC, Binoodles, the linker. In recent years, with the advancement of static analysis technology and compilers, it has become possible to prevent an entire classes of vulnerabilities before they even happen. At least in most cases, hackers are clever and are beginning to get around it, but we do have at least most of the obvious stuff covered. Now, I'm not a compiler designer, so I can't really tell you how that all works. All I know is that it's there. It broke stuff. We fixed it. Now, integer overflows, stack smashing, and all other classes of vulnerabilities don't happen, or at least are harder to get to work than they used to be. It used to be trivially easy to exploit a Unix box, and this applied everywhere. FreeBSD, anything. All you had to do was find a buffer overflow in a set UID binary. So all you had to do was find a buffer overflow in ping, and you were golden. Now that doesn't happen. Or at least it's harder. So if you want specific details about what we're doing, see me after, or what the team that's responsible for these things are doing. So the next important step to securing a Linux distribution is securing the channel of distribution. Your apt, your yum, your DNF, your whatever package manager you have, it has to not install anything it's not supposed to install. And that's turns out to be harder than it looks. Because we can't use traditional TLS security on repositories. Anyone know why?
No, why?
because we'd have to rely on commercial CDNs in that case. Basically, if you have one central server, you have bandwidth problems, and a distributed system is much more secure than a centralized system every day of the week. So what the major distributions have adopted is they sign their repository index files with GPG. Now, what a repository index file is it lists every binary package, every RPM, every deb that's available in that repository together with its secure hash. SHA-1, MD5, whatever. It really doesn't matter. So after apt is done downloading, the first thing it does is check the MD5 or whatever hash you're using, and you should be using SHA-256 unless you've royally broken your apt configuration, which is very hard to do these days. So the first thing it'll do is check against its database of hashes. And it won't install anything unless the hash matches. But anyone want to know what can be the difference between a piece of software with a remote hole and a piece of software without a remote hole? 1 bit. 1 bit in a binary can often mean the difference between a vulnerable piece of software and a not so vulnerable software. So basically, we use PGP to make sure that no man-in-the-middle attack happens, because it's trivially easy to change the MD5 or the package, the signature of the specific package you're working on, and flip the bit in the binary if you're using TLS alone. So PGP is used to sign the index files, and that's secured, and that secures the channel of distribution in most cases. The FTP master team of Debian, and there are similar teams in Red Hat, are constantly doing research on this as to how to break it. So they discover vulnerabilities before the hackers do in this particular piece of infrastructure. So so basically 2 attacks that have been prevented before they were ever able to happen in the wild were the replay attack, where you replay a known vulnerable version of the software as if it's current. There was no way to detect that until 2010. Now there is. It's called valid until it simply date stamps the release files. And the other attack was not so much an attack, but a design flaw in apt. And I only know specifically about Debian. So the design flaw in apt that was discovered was basically any key that was registered in apt as a valid signing key would be accepted for all repositories. There was no way to detect what repository went with what key. In new versions of Debian, Jessie onwards, it's no longer possible to do that. So that's repo security for you. And I'm being terribly boring, but...
Well, one quick question. Once a repo is compromised, the way the Linux Mint one was, how long is the cycle time until it gets set by the correct teams to no longer be distributing malware?
Well, Linux Mint was a compromise of their ISO media, not the repository itself. Now, if you compromise a repository, say you break into a repository server, if you have access to the repo server, it's trivially easy and might be undetectable if you compromise the repo. Because the way automatic signing works on repo servers is you have to have the passphrase to the GPG key in memory every time you do a update of the repo, which no one wants to do. Everyone wants to get their changes in fast and make it work. So no one wants to be the guy that's standing by to enter the passphrase 24 hours a day, 7 days a week. So, what they do, what most repos do, is have a key that is not password protected at all. So, once you have that repo server, you own the whole distribution. And there are two ways of preventing that. And both are usually employed by good distributions. One is to make the repo server as difficult to hack as you possibly can make it. Which, back when I ran a repo, I made it so you had to have PGP encrypted port knocking on it. So the firewall wouldn't even let you in unless you were me or had access to my GPG key in any event. And the second way to do that, to secure against a repo compromise, is to have everyone knows how PGP works and will understand what I mean by revocation certificate. So basically what Debian, and I think Fedora does this as well, is have their revocation certificate and they put it through a secret sharing scheme and give the secrets to geographically distributed persons that are trusted. So basically, there are 12 people in Debian who sort of watch for a repo compromise. And if it happens, they get together and if seven of them agree that the repo has been compromised, they're allowed to revoke any key that Debian has ever used. So once that happens, apt will stop working.
Thanks.
And that the time it takes varies.
But
Now,
it sounds like it's measured in hours, not days or weeks.
I don't know who's currently on staff to do that in Debian, but if the people responsible for doing that were anything like the people responsible for checking out security vulnerabilities back when I was actively involved, it would be measured in 48 hours at the latest before you have German people cursing at you into him. And then if that doesn't work, they have French people curse at you. And then the Swedes get it. And it's not a fun day when you have a major problem and you're not taking care of it. Now, Linux Mint, as far as I know, doesn't have any of these security procedures set up. So what amazes most people that know anything about Linux distribution security engineering is not that a Linux Mint hack happened. It's that it didn't happen sooner. And you can see you can look at LWN comment sections and mailing lists to see the reaction from the community as this happened. I bet they didn't have Clem's phone number or they would have been cursing at him. So the next bit of security management in Linux distributions is called patch management or change management. See, all the repo security in the world is no good if you don't tightly control who has access to change the repo at any given time. And so the idea is any change in the distribution, you will know who did it when, and hopefully why. So you want as public a record as possible. And on Ubuntu, you can install Debian-keyring and run a command to get a list of the 1,000 or so people who have direct commit access to the repo and their email addresses. So, as an active distribution contributor, you get a lot of spam emails. I get like 5,000 a day. And I haven't been involved in about a year. So, because even without direct access, the person with direct access better know who made that change, when, and why. Otherwise, they won't have access for very long. And at least the Debian people, and Slackware too, are very serious about who gets access to what. You have to go through a whole identity validation process where you go to New York City, show them your driver's license, and you have to take a test. It's like the worst final you've ever had, and it's individually. And when you go to apply for commit access, they've been watching you for typically a year or more. I don't want to face my own committer's exam yet because they know exactly where I'm likely to mess up. And they will ask you those questions. And Fedora is similar. They have not PGP validating their committers. They have SSL certificates, X509 infrastructure, which is a bit easier for Red Hat Inc. to manage centrally. And that's a bit of a security flaw there, but or could be potentially. But as long as they're maintaining their correct procedures, air gapping their central signing server, that's not much of a problem. But as I said, in security, decentralized systems beat centralized systems any day of the week. Hang on. That better not be.
Be that German guy.
I wouldn't be surprised if someone from the community was watching this. Would not be surprised in the least. Now the next aspect, I don't have a slide for this because it's kind of free form and there's no set process because every security incident is different, is what happens when you discover, or it is discovered, that a security vulnerability exists in some part of the system, in, like say Bash, or we had the shell shock vulnerability a couple of a year or so ago. So what happens when a vulnerability like that is discovered? Well, you all know what CVEs are, right? They're basically public reports of security vulnerabilities that exist in a piece of software. Debian has what is called the security incident tracker. Basically, it's data mining, and Fedora has a similar thing, but it's not. I don't know enough about their procedures to tell you what it's called or how it works or anything. So basically, they're data mining the CVEs for any bug that applies to a package in the distribution. And when something like that is discovered, you get a friendly email. And if you don't respond to the friendly email saying you have a security problem in your package, or one of your teammates doesn't respond, for example, you typically get an annoyed email from a human. And if you don't respond to that, they attempt to find other contact information other than your public email address. And that's at the point where you get German people calling you at 2 in the morning. And basically they say, you have a problem. Fix it, or it's going to be bad for you. And so basically, if it's a publicly reported vulnerability, it'll get uploaded as soon as it's done. And it better be done fast. Like, a week is the furthest it's acceptable to be at for responding to a security vulnerability before you get annoyed calls, and eventually your access to commit on that package is revoked and the security team takes over, and it's a very bad day for your reputation. Anyway, but if it's a private vulnerability, things work a little bit differently. Because private vulnerabilities are private. So the reporter of the vulnerability, or whatever organization responsible for assigning the CVE, will typically reach out to the major distributions, and and if it's bad enough, the major distributions will reach out to the minor distributions. And so typically the process works such that the patch is already in and fixed as soon as it's public. So as soon as the vulnerability goes public, you have a patch in the already built, ready to update, ready to go. Now for 0-day vulnerabilities, slightly different. Because 0-day vulnerabilities will get, depending on how serious it is, we'll get the security team involved. They're involved already in all security aspects. But it will get, the security team will go hands-on. They usually like to leave it to the individual committer to fix their own security, to fix security vulnerabilities for which they are responsible. And people are leaving, so am I out of time or am I just boring?
Don't worry about it. Keep going.
Okay.
The people who need this are staying.
So, my first talk, and I'm a bit nervous. So that's how CVE response works. And I haven't been involved in about a year in Debian work, but hang on. Now that'll stay there. Sorry. I almost got another annoyed German phone call if my teammate hadn't been able to take care of what was going on. Because the vulnerability in a package I was responsible for was spotted last week and I didn't know about it. And I will be asked when I go back in May, end of May, to contribute to Debian. Where was I when this security vulnerability happened? And so security is taken very seriously in most major distributions. Like I said, in the minor distributions in the router firmware, it's not at all. with Linux Mint and a bunch of the smaller distributions, they typically only have one server on which they put their website and their ISO distribution and their build system and everything. So compromising that one box through PHP, or WordPress or whatever is the keys to the kingdom. Now, Linux Mint was very lucky, and this is the only case study in recent years. If you want older case studies of what happened to the major distributions before they smartened up, they look a lot like the Linux Mint case study would. But Linux Mint is the only major case study of a major breach in a distribution we have. So what happened there was basically the download server, as I said, was compromised and not replaced with a malicious version of the distribution. They inserted a package onto the ISO. They slipstreamed it onto the ISO, which is very easy to do if you have the ISO building tools right on the system there. And we're at the point in the talk where I expect questions, so just stop me there. So they slipstreamed a piece of Linux malware called Tsunami, which is basically a standard botnet, such as you'd get on a drive-by download for Windows or Apple. But because they had control of the build servers, they could build it specifically for their target distribution. Not all malware for Linux works on all distributions all the time, because it's so heterogeneous, and that's part of what makes Linux more secure than any other platform out there. Or FreeBSD might be able to boast of more secure. OpenBSD, they only get a better security record because they're paranoid and no one uses them. That's exactly. But so they inserted this malware onto the disk, replaced the MD5 some on the website, and bang, they were in business. Now, because Linux users are smart, and or most Linux users are somewhat smart. That's the other security. That's the other bit of security in this puzzle. It's you and I. It's all the enthusiasts, all the Linux users out there who notice this stuff, who are paying attention. This was spotted within hours, and they shut down the download server and got everything all squared away eventually. But the only reason this wasn't as bad as it could be and the only reason this was able to be noticed was the guy who did it went and bragged to ZDNet and made his malware obvious. Now if you were going to be really malicious, you could do a bit flip in the SSL package and make it vulnerable, or insert a rootkit into the ext4 or XFS drivers, and then not brag about it. But you would still get noticed.
So this probably has happened before with distros like Mint or other smaller ones where there's only a few people managing, right?
We don't know, and as long as they maintain their security practices correctly, it shouldn't be a problem.
So I find it interesting you keep referring to Mint as one of the smaller distributions, because the figures I'm seeing show that in terms of user downloads, Mint is like more than all the rest put together.
Mint has a lot of users, but is only managed by 3 developers who are very good at graphical design and making things look pretty. They're amazing at that. I installed the Mint user interface on top of Slackware. That's how good it is. that people from other distributions pull their software and are installing it on their own systems. But because they don't care about low-level engineering, and because they're a poorly funded team, and don't really understand the security implications of what they're doing. I mean, we have some of the Debian, Red Hat, and the other big players in the distribution market have some of the most talented security researchers in the world working for them. So if you're starting a distribution, if you're doing embedded device work, if you're doing anything like that, you should learn from them and learn from their mistakes, and take a stand on the shoulders of giants, in essence, because Debian, Fedora, and everybody else have already done all of this security work for you, and it only so it doesn't take a lot to re-implement or use what the bigger distributions are using. So, but Linux Mint didn't really care about security and about correct low-level engineering before they had to care. I bet they're caring a lot now. So don't put the ISO on the same server as the website. Don't put your build system on the same server as your website.
What are forums? Forums on the same server.
Okay. Rule number 1 of web applications and Linux distributions. Don't put web applications on the same server that runs your download site. Don't put... Debian's website is statically compiled. It's all a bunch of HTML files. There are some CGI scripts. But the Debian user forums, which are run by Debian, are on a completely separate server, on a completely separate in a completely separate geographical area, on a completely separate subnet of the VPN. Apparently, I don't know this for sure, but when the Debian user forums were hacked a few years ago, I think it was 2011, somewhat, nothing happened other than the forums were hacked, and that sucked. But it had no distribution-wide consequences. Now, if a server like the Debian master server were hacked, or Rise, or Alioth, which are the central infrastructure of the project is managed by those 3 servers. So if those 3 servers get hacked, it's not going to be a good day. And it wasn't a good day in 2005 when they got hacked. Or one of them did. I forget exactly which one, but it doesn't really matter. And it's very hard to hack those servers. So I went off on a tangent there, but back to the original question. Linux Mint is small in terms of development team size to what they're trying to accomplish. And that's what matters. I mean, they could easily, not distribute ISOs and just rely on Ubuntu ISOs and a little script to get their stuff working, but they don't do that. They want to distribute the ISO themselves. And that has security consequences. So, anyone have any more questions? Because I'm running out of material. And I still have 10 minutes. Who? Where?
I'm in the back.
Just let me know if this is a little bit off topic.
Nothing's off topic. I'm the king of tangents, so.
You mentioned a couple of times, flipping a single bit
Yep.
in order to make something quotable, and other than maybe checking in a hash that doesn't match or whatever.
However, have you ever, do you program?
A little bit.
Have you ever done a greater than sign when you meant to put a less than sign in an if?
Sure.
Everyone does that all the time. And the problem is, at least for x86, the opcode, the machine instruction that essentially controls what the computer is doing for greater than or less than are 1 bit apart. And depending on where that is in your program, you could easily have a remote hole. And there are other opcodes which are 1 bit apart or inserting an extra byte, and it would still work, but it would cause a remote hole. It all depends on knowing the software itself and knowing how it's assembled and everything. But you can manipulate it. There is a classic case, and this was discussed at the Chaos Computer Club meeting of 2014. I can look up the exact talk title if you want, that conclusively demonstrated that you could have a remote hole by flipping 1 bit. So binary manipulation is a thing. Now, there are no recorded cases of it happening in the wild, but who knows? Like, North Korea distributes a Linux distribution. Who knows what they're doing with it? And China has this great firewall that can do deep packet inspection and whatever. So who knows what they're doing with that? You could easily get an encryption backdoor if you had, to build on what was earlier talked about, if you were at the keynote, you don't even have to legislate it. You can, if you control the internet, the pipes, you can theoretically control everything. So does that answer your question?
Yes, thank you.
Over there. And
how do you commit to interface with a more secure system? How do you download the graphical GUI you want without all the other security holes?
You install Debian and look up mate on Debian or cinnamon on Debian, or Slackware has even better support for this. You can essentially download cinnamon or mate. Like, if we can get out of this, I'm using
Distros have cinnamon spins.
I'm using mates on. Yeah, and there's cinnamon spins that are attached to larger distributions. Ubuntu Mate Remix is a good one, and I believe there's one for cinnamon coming out as well. I don't know if that's out yet. But basically, the software that's a user interface is disconnected from the distribution. So you can essentially do it on any distribution if you know how. And the distro overlords, being the good people that we are, have provided ways to do that on a more secure distribution. So Debian, Fedora, anyone will have this sort of capability. You just have to look for it and not reflexively download Mint because it's easy. And I don't mean to rag on Mint.
Yes, you do.
Actually, I do, because well, it may seem like I'm picking on them, but this could easily apply to any small distribution like SolidXK or Aptusid or Apasid or whatever it's called. This could even apply to Slackware if the people running it weren't smart and paying attention and everything. So that's about all the time I have, I think. And Basically, I'll answer questions until they kick me out. There. You.
Okay. Sort of a new user for Linux, but who are the major, I guess, stakeholders, actors who would have an interest in compromising Linux distributions?
Anyone. You could compromise. I applied this to the major distributions, but it could easily apply to the firmware in your TV. Everyone's using Linux now. It could easily apply to your phone. It could easily apply to anything that runs Linux.
Who would want to do it?
Who would want to do it?
Yeah.
Generally, anyone with an interest in hacking those things for any purpose.
Monitor you, type of thing.
Yeah, monitoring. There could be trade secret implications. Like a lot of development companies use Linux as part of their development work. Like, so trade secret theft, just sort of anything you would want to hack anybody over. A distribution is a way in, as with any other operating system. So does that answer your question?
Yes, sir.
Do I still have time?
Yes.
Anyone have any more questions?
So you're going to start your own again?
Um,
And be like men? No? Okay, good.
No. I'm probably going to do a proof of concept distribution that does some weird things with the kernel, but that'll stay in the lab for now. So does anyone have any more questions, or can I? Over there in the.
Are you familiar with like cloud services like Amazon Web Services that distribute AMIs or machine images?
Yes, I know they exist, but I don't know about their specific procedures for securing that image. So theoretically, a hacker who is inside Amazon or inside DigitalOcean or any sort of cloud provider could slipstream a piece of malware, a rootkit or whatever, inside those images as well. That's another aspect that I didn't cover because it's way too broad to actually cover, but theoretically anyone could attack. That attack also works. So those images better be secure. So do I still have time or? Okay. Does anyone have any more questions? This is really kind of embarrassing, running out of material 10 minutes before the talk ends.